In this video, we will be talking about relations and functions. A relation is just a set of ordered pairs where we have inputs and outputs. So usually we write it in the form x comma y, where x is our input and y is our output. So you can see for this example, we have the set 1, 8, 1, 2, 3, 5, 7, 2, and 2, 6, where we have all of them in form x comma y. So 1 comma 8 is x comma y. X is our input, so 1 is our input, and 8 is our output. And this whole thing is going to be a relation. The domain is the set of inputs, and if the input is repeated more than once, then we don't have to write it both times. One time is enough. So see, we have an input of 1 for 1, 8, and then again an input of 1 for 1, 2, but we only have to write that 1 twice. And then we have a 3, a 7, and a 2. The range, on the other hand, is the set of outputs. Same thing goes for them. If we have more than one of the same number, we only have to write it once. So we have 8, 2, 5, 2 again, and 6. So this is our domain and the range. As far as a graph is concerned, the domain is usually called the x-axis, and the range is based on the y-axis. So, for this exercise, we're asked to find the domain and range of the following two relations. For A, we have 2, 4, 1, 5, 2, 6, and 1, 7. And for B, we have 1, 3, 2, 5, 3, 3, and 4, 2. So first, we'll find the domain of both. We'll abbreviate that with a D. The domain of A is, again, the set of inputs. So we have 2, 1, 2 again, and 1 again, so we only have 2. And for B, the domain is 1, 2, 3, and 4. The range of A is the set of outputs, or the y values. We have 4, 5, 6, and 7. And for B, our range is 3, 5, 3 again, and 2. A function is a special type of relation, and it's basically where each input only has one output. So each input only has one output. That means that we'll have no repeated numbers for inputs and outputs. So like for the first example, we have 1, 8, and 1, 2. Since 1 has two different outputs, an 8 and a 2, it's not a relation, or excuse me, not a function. So if we look at the two examples we just did, A and B, A has 2 and 1 as inputs, and 4, 5, 6, 7 as outputs. And since there's not an equal number of inputs to outputs, it's not a function. For B, we have 4 inputs, and we have 3 outputs. And since each input has only one output, this is a function, because even though there's not an equal number, each input, so each 1, 2, 3, and 4, all have different outputs from each other. So this is a function. The equation y equals x squared is shorthand for all ordered pairs of the form x squared, which basically means for whatever value you put as your input, their output is the square of that value. So for example, we have 1, 1, 2, 4, 8, 64. Other ones would be like 9, 81, 3, 9, etc. So this relation, y equals x squared, is a function because for each x there's only one y equal to x squared. So you're never going to have an input of 2 and an output of anything but 4. It's always going to be that, and there's no other number that will give you the same output. Our last example asks us to find the domain and range of the relation y equals x squared plus 1, and then determine if that's a function. So the first thing you're going to want to do is look and see what the domain and range are of this function. We could also first graph it, and graphing these sometimes helps because it gives you a visual of what you're looking for. So if we graph this quickly, we know it's going to look like a parabola because we have the x squared term. And if we pick out a couple points, if x equals 0, y equals 1. If x equals positive 1, y equals 2. If x equals negative 1, y equals positive 2 again. So, if I do that better, it's a parabola. So when we look at the domain, we said it's all of the inputs, which is all of the x values, which is basically where can this graph exist in terms of the x-axis, which is this horizontal axis. And we can see that x can extend from 0 to positive infinity and from 0 to negative infinity. So we see that's all real numbers, which we can write as that scripted r. We could also say negative infinity, x, infinity. So all three of these are acceptable answers for this domain. For the range, we see that we want to look at the y-axis and see where does this graph exist on the y-axis. Since it goes from 1 up to positive infinity, we can say that our range is going to be y greater than or equal to 1, which basically says it can be any number above 1, but it will never go below 1. And then lastly, we're asked to decide if this is a function. And if we look at this, if we have an input of 1, it always equals 2. It'll never equal anything else, even though that there are two places where the function equals 2. The inputs themselves are unique, so this is a function.